Let us have one example. So in this example, suppose that you have an exponential PDF. An exponential PDF is defined by this function. The CDF is, if I want to plot it, this is x, and this is, let's say, f(x) of x. Because here you have a unit step function. Unit step function ux is defined to be equal to 0 for x being negative and is equal to 1 for x positive. So therefore your CDF is equal to 0 for negative values. So here you get 0. At x equals 0 you get 1, and then you get c e to the power minus 0, which is 1. So you get a value of c, and your function will decrease exponentially. So this is exponential. Now if you calculate f(x) of t is equal to integral from x from minus infinity to time t of f(x) of t, x dx. Remember that this x is dummy variable, this is a real variable, so you get this expression, which is your CDF is 0 for negative values. For positive values at t equals 0, you get the 1 minus 1, so you get 0. And at t equal infinity, this becomes 0, and this 1 will stays there, and this becomes 1. So at t equal infinity, so let's say 1 is here, asymptotically your function will go here. So you have an exponential function which will go to 1, from 0 to 1, and this is a continuous type distribution. So for this distribution, if you calculate the PDF of x given this event, so you can, from the previous slide, in this slide we had, you have to define the PDF of x divided by the reliability at t, and if I use this expression, so I should have f(x) of x, which is c e to the power minus c x u of x, and then divided by the reliability, which is 1 minus this function. So 1 minus this function will become e to the power minus ct and ut. So these both, I could say that this is valid for x bigger than t and bigger than 0. So this is going to be equal to this function. So if I plot this function, so what I could see is that I get this is equal to c e to the power of minus c and then x minus t. So the PDF, if I plot it, it starts as c and exponentially reduces, but the new PDF, provided that system is functioning at time t and I'm at time t, I want to have this PDF updated given this condition, given this event, is going to be the same shape. The only difference is that it's shifted to the right and so on. So this system that has functioned up to this moment is not much different with this one. So it's kind of like the PDF is shifting with time with you, as long as there is no failure. Of course, if there's a failure, then you don't have. So this is called a memoryless system. If the PDF is exponential, we call it memoryless system. This is the only PDF which has this one, the only continuous type. For discrete type, you have a geometric, which is also like exponential degree. So the property that the conditional PDF given this event is just the shift of the original PDF, means that the reliability of this system is not changed as time goes by.